Good morning or good afternoon, depending on where you are. My name's Peter Rumsey. I'm the founder of the Stanford Building Decarbonization Learning Accelerator, the BDLA. And we thank you for attending today. We have a really exciting webinar. I'm very much looking forward to it. Couple ground rules. If you do have questions, we'd ask that you put it in the Q&A. And then after our guests are done speaking, we'll go through the questions and they will answer those questions. Lindsay Frano from the BDLA will be helping to facilitate the Q&A period. So with that, and make sure you're on mute because we have a Zoom webinar thing. I think the being on mute is not too important. I think we can mute you, but just do go ahead and make sure you're on mute. We are going to offer, if you would like to ask your question um, by asking it instead of typing it in the Q&A, you can do that. Just put in the Q&A, I'd like to ask it verbally, and then we'll allow you to be unmuted and ask the question. So anyway, it should be fun. Um, so let's go ahead and get started. And I want to introduce our two speakers. Our topic for today is on full decarbonization and of the AIA headquarters, which is a super exciting, very forward-looking looking project that Rebecca and Rami were leaders on the design. So it's wonderful to have them here, and I think you're going to learn a lot of exciting things. And this is where they put together so many of the concepts that we have been promoting through the BDLA teaching materials, and would urge you to go to our BDLA website, bdla.stanford.edu, and there you can download teaching materials, everything from slide decks to teaching assignments, case studies, and even our webinars have been recorded. So we're trying to create a set of tools that are useful for you as teachers of this topic of building decarbonization. So let me start with the introductions. Rebecca Sharkey is a principal at EHDD Architects in San Francisco with over 25 years of experience, both optimistic and she's both optimistic and passionate about the power of design to enhance people's lives and the natural environment. She prioritizes climate action in her work, focusing on reimagining existing buildings to strengthen cultural, financial, and ecological resilience. A key tenet of EHDD's climate positive practice. Her projects include the renovation of KQED's headquarters in San Francisco and the AIA headquarters renewal in Washington, D.C. Rebecca also brings expertise in community, cultural, and higher education facilities with an eye towards creating sustainable places that inspire and engage. So thank you, Rebecca, for joining us. Rami Musa is a managing principal and co-owner of Point Energy Innovations, where he leads high-performance building engineering with a focus on decarbonization and energy efficiency. As one of the only engineering firms exclusively focused on integrating building decarbonization into the early stages of design build projects, he continues to push the boundary of cost-effective low-carbon solutions. Rami was awarded a top 40 under 40 in the engineering industry this past year, and he intends to keep innovating for the critical decades ahead. So these are two leaders in the field of building decarbonization, and we welcome you and look forward to your presentation. Thank you, Rami and Rebecca.
All right, thanks, Rami. So we're going to get started. If you jump to the next slide. We're just going to start with a quick overview of the building and our design approach before we get into the decarbonization story. So the AIA Global Campus is located in Northwest Washington, D.C. It's about 2 blocks from the D.C. Mall and the White House. The original headquarters building is that iconic brutalist structure at the back of the site. It's also known for its surrounding courtyard and the adjacent brick octagon building, which is a National Historic Landmark the original home of the AIA and now occupied by the Architects Foundation. This Brutalist headquarters building was designed by the Architects Collaborative and celebrated its opening day in 1973. Next slide. So these are just a few images from the original building opening and winning competition entry. The building was designed as a backdrop to that historic octagon building. It's defined by its sculptural forms, a very curated visitor journey, and just all the frame views that look back out to the courtyard. This article here from the Architects Journal noted that the new building at the time is a welcoming new face for the AIA, which was ironically one of our goals for the new transformation. Next slide. The AIA had many goals for both design and sustainability excellence, as you can imagine, while also wanting to create a dynamic new workplace and transform experience for visitors. So the unique approach our team took in synthesizing all of these goals was around the theme of advocacy and transforming the building into a place that advocates for all the people it serves, our planet, and the profession at large. These are just some of the key themes highlighted here, including our climate positive approach, which we'll be talking about today. Next slide. So I'll start with an overview of the facade design, which was an integral part of our decarbonization story, and also our team's shared belief that good design should equally prioritize performance, beauty, and delight, as described in the AIA's framework for design excellence. So we kept the existing facade with the building, which is a significant part of our embodied carbon strategy, which we'll talk more about today. And then we upgraded it to make it as energy efficient as possible. Our big design move for the exterior was adding a new external PV sunshade system, which would enhance the building performance and interior experience, while also feeding energy back into the building and creating this welcoming new presence for the campus. Next. The original Architects Collaborative building was very agnostic to these two unique solar exposures of south and west facing. So our team studied the sun path and how it moved across the building throughout the day and the year, with our goal of trying to better tune this existing building to its surrounding context. Next slide. We identified all the unique angles and parameters that would be needed to address each of these unique exposures for both solar shading and PV performance, and then a variety of technical constraints of working with this existing building and the existing facade, such as the limited ability to add new loads without increasing the structure and the cost. Next slide. So then bringing that all together, our new sunshade system creates this sweeping gesture across the facade. It's south to west, and it really complements the original ribbon windows that were such a character-defining feature of the original design. Next slide. Here's some photos of the almost complete installation on the left. So you can see the form of that sunshade system and the integral frit pattern that we applied to the PV glass that would help control heat gain and glare, while also providing a very dynamic and dappled daylight effect as the sun passes through it. And then the photo on the right shows the two smaller street-facing sides of the building, where we applied a similar frit pattern directly into the glazing to enhance building performance. Next slide. This is a view of the interior showing how that dappled daylight effect creates these really nice shadowing effect on the floors of the inside of the building. Next slide. And then zooming back out to a render view of the full site. The site is still under construction and will be completed by the end of the year. But this view just shows how the new facade and the landscape design together really transform that formerly austere and uninviting campus into a much more open, welcoming, and biophilic experience. Next slide. Biophilic design was an important design strategy throughout the building, inside to out, to help us create this welcoming experience. So our approach focused on enhancing daylight, natural materials, interior plants, and more. Next slide. We also added a lot of new ground floor public spaces and programs to enhance the entry experience and create this dynamic new destination that people would want to keep coming back to. So this image shows the new coffee bar and ground floor lounge area. And next slide. We also have a new exhibit space with rotating exhibits about AIA's values of design excellence and creating a healthy, just, sustainable, and resilient future. Next. And then finally, a view of the renovated atrium space showing a new floor opening we carved to extend the ground floor atrium down into the formerly dark and closed off basement. And here you can see the mass timber feature stair we designed to connect those floors. And it's also one of the visible features of our embodied carbon approach, where we prioritize carbon sequestering materials like wood over more carbon intensive materials like concrete and steel. So next slide. So this brings us to our decarbonization approach, which started at the proposal stage of the project before we even won the project. So in this case, the AIA's goal for the RFP was to achieve the AIA 2030 commitment, which focused on having a building that reached carbon neutrality by 2030. So based on this goal and budget and space constraints, the AIA initially planned for a zero energy building and then having the ability to phase in carbon neutrality in the future. So this is shown in the carbon emissions graph on the left. As our team was developing our approach to the project, we explored a variety of scenarios to drive carbon down even further. So we looked at a clean electrification scenario, which would address operational carbon, as shown in the middle, and then a variety of embodied carbon strategies that could ultimately get us all the way down to zero on day one and within the project budget. So I'm going to hand off to Rami to start walking us through our approach.
Great. Thank you, Rebecca. Yeah, so that early concept, shifting from the mentality of zero net energy on site to really looking at the bigger picture, the most impactful metric in our field is how do we get carbon impact of this building to zero, both from an embodied and operational perspective. When we start here, we've got to consider the life cycle carbon impact, not just day one. When we think about operational, it's over the course of time. So this is a graphic from the EPIC tool, which was used to estimate that life cycle total carbon impact of the building, embodied, relatively solid and steady over time in red, and blue on top, seeing that emission impact increasing over time as we continue to consume energy and to replace equipment, maintenance, refrigerants, et cetera. Okay, so the goal here was how do we get that down? And starting with the blue portion, the operational energy, we consider decarbonization in a relatively simple framework. And this is applicable on both existing buildings as well as new. Typically, we begin with a conventional, whether it's code-driven or a developer cost-driven approach of just what's necessary, what's the least expensive way to build a building. That's usually a mixed fuel building conventionally, maybe code prescribed window wall ratio. You get to a relatively similar architecture there. The first step towards cost effectively decarbonizing is with efficiency. There's a core step of this journey towards decarbonization. And that efficiency is investing in passive systems like your envelope, external skin systems, as well as the internal mechanical components, and making those as efficient as cost effectively as possible is the first step there. Then, once our systems are reduced in size, we can electrify those systems, be it boilers converting to heat pumps, water heaters converting to heat pumps, or electrification of kitchen equipment. We first want to get to the most efficient point possible, then invest in electrifying in the smallest equipment that we can to reduce its cost impact. Last step for that full decarbonization operational emissions is our use of renewable energy, both on-site and procured ideally locally. A big component of making this also cost-effective is demand management, and batteries are becoming a bigger part of the picture in the current years. Okay, so that first step, efficiency, really the biggest focus here is on the skin. We have an existing building with the AIA headquarters with a heavy concrete cladding on the exterior facade. The embodied carbon within that concrete is tremendous. So just stripping it off and replacing it with a new was a non-starter for the project. The opportunity here was to how do we, number one, improve comfort? How do we reduce cooling energy? How do we reduce glare? And this exterior shade system that Rebecca spoke of is really that core component that allowed us to do that. We also incorporated PV into that, right? So activating that surface. But the core part of this was develop a shading approach to protect the glazing, improve comfort, and reduce energy use. And then also enhance the insulation behind the opaque portions wherever possible. So thick insulation was added behind these concrete cladding components and all of the opaque surfaces, be it the roof or exterior walls. Next step, electrification, was first stop here was the steam boiler system. 50-year-old steam boilers that were near the end of their life and a great time to electrify. But these were some large pieces of equipment that if we replaced, say, one for one with heat pump capacity, we wouldn't have enough room on the roof to get that much heating capacity within the building and heat pumps. So again, that efficiency step, adding the insulation, improving the glazing, going from single pane to double pane IGU, integrated glazing units, and reducing that heating demand allowed for this array, this heat pump array on the roof that you see here today, that meets the building's heating demand at a dramatically lower total capacity than the steam boiler system. Water heating was also electrified here, going from combustion-based storage water heaters shown on the left to heat pump-based equipment shown on the right. So this is a internal heat pump to this tank-style unit, where compressor and heat pump components are up on top. You can see the little fan inlet there. And then heat is pushed into the tank and into the stored water there with two tanks in parallel to meet the building demand. Okay, so with those, we were able to dramatically reduce the operational emissions just through efficiency, not yet through the renewable energy story, but efficiency alone allowed us to take a huge chunk out of that life cycle emissions of the building. Okay. When we move toward eliminating, bringing that operational emissions to zero, we have to look to renewable energy. So we've got all electric systems, now let's fuel it with clean energy. The building proceeded with about as much PV on the roof as we could get, given the constraints of the heat pumps and the existing penthouses and visibility requirements here on the roof. So you can see in blue the portion that we were able to cover on the roof with active PV modules, as well as the facade. But about 90% of the building's annual energy use is procured from offsite. Again, broadening the lens from just site energy to total carbon, which we're able to more cost effectively offset with using locally procured renewable energy. And that was available through PEPCO's local program called DC Power Connect, where clean energy can be procured locally. Okay. So taking on-site generation to the most practical limitation here, and then relying on local renewables to fully offset those emissions and annual energy use. Okay. Now, the budget for installing that solar on the roof can be a challenge for some projects. And this project relied on a creative procurement approach of using a power purchase agreement. Other approaches might be a leaseback type of arrangement where there is just about zero cost impact to the day one capital that was AIA's expense to construct a building. And a PPA agreement was established with a local provider to install the panels, maintain them over time, and ensure output at a small discount to the benefit that the AIA receives in offsetting energy costs, but most importantly, also offsetting the building emissions for that 10% that was mentioned previously. So in this arrangement, generate power locally, utilize it or export it to the grid, and for those hours that solar energy generated on site cannot be met, we procure renewable energy to fully decarbonize operation. Okay. Through efficiency alone, we achieved about 50% annual emissions reduction, here shown in this first step down in this bar chart. And then lastly, we made our full offset with both on-site and off-site renewables here. Now, we talk a lot about how we achieve decarbonization from a technical perspective, but really the soft side of things and how we actually get to this reality of a decarbonized building is a very different conversation. It's not just about numbers on paper, but it's about how do we as a team come together and work together continuously to keep the project driving towards this ambitious goal, right? To get there, especially in a cost-effective way, that integration is crucial, right? We need an owner that is clear on their objectives, has a clear charter and a decision-making process, so that everyone can bring their best value to the table and stay on course. We need the engineering team to be creative and create an integrated design approach with comprehensive evaluations that don't just look at energy, right? It's not just about zero net energy, but it's about what is the holistic impact of our system decisions, from emissions to comfort to maintenance requirements and really cost. How do all of those components get to the best value for the owner and make that design approach that is decarbonized stick? We need architectural partners to lead that approach with the owner as well in maintaining the project priorities. And they equally have their part in the design of, it's not just about the mechanical systems, right? It's not just the directly emitting systems, but the integrated high performance passive systems that enable the cost-effective mechanical systems. So we're all working together as a team, and having a contractor or builder partner at the table as early as concept programming in a design phase, where these ideas are just being conceptualized, is critical for cost feedback and making sure that our goals are attainable and realistic. Setting expectations early and making sure that we can get to this final milestone. And that is not a cost or feedback that is static in time. It changes over time, be it additional detail in projects, cost escalation, whatever it may be. That partner needs to be along for the ride the whole way through. So continuing with iterative and transparent estimates. Okay. And that gets us to our last step here of our embodied carbon. How do we offset that? Right. I have a similar framework here, and I'll pass it off to Rebecca to walk us through that.
All right, thanks. So that was our approach to embodied carbon is outlined here on this slide and follows a similar strategy to what Rami outlined for operational carbon. So just a quick overview, we try to reuse existing materials and furniture wherever possible as a first step, and then source carbon sequestering materials like that mass timber stair I mentioned when available. And then for all other materials on the project, we prioritize low to no carbon materials. Next. For this project, as we started looking deeper into the embodied carbon footprint, we started by exploring 3 scenarios to assess our potential for impact. So these graphs show the breakdown of material categories and how we looked at each of the carbon impacts of all of the various material categories as we moved into the later stages of design. So on the left shows a new construction scenario that we set just as a baseline for comparison. The middle scenario is renovating the AIA building, so the building reuse, but keeping conventional materials, which just allowed us to isolate the carbon impact of reusing the building alone. And this middle scenario also let us see that if we were to continue ahead using typical industry average material choices, where the greatest impacts of embodied carbon would be, and therefore where we can focus our efforts in the design phases to create the greatest impact. So the third scenario on the right was our as designed project and targets for this project. This reflected additional carbon reductions using the strategies I described earlier, and really bringing down through material reuse and optimization strategies. It shows the impact we are able to make. So we're able to bring our embodied carbon down by an additional 30% from the middle scenario and almost 60% beyond the new construction baseline. So next slide. This effort, sorry, if you just go back one, we just like to highlight that this effort also brought to light for us what a big impact the interior design decisions can have on a building's carbon footprint. So in the embodied carbon conversation, there's so much attention on steel and concrete. But in cases for retrofit projects like this, where we're not doing a new structure and a completely new skin, you can see what a big impact the interior materials have on the embodied carbon totals. So in this case, interior materials are about 44% of the total embodied carbon of the building, and over 50% when we also combine that with furniture. Next. So this is just a closer look at the specific reductions we were able to make by material category. Some examples, we were able to reduce the interior concrete, masonry, and cement by over 65%. This is just through kind of similar to what Rami was describing, deep collaboration with our design team, subcontractors, and structural engineer. We were able to push the limits and find the best locally sourced options just by asking the right questions and allowing time for these conversations. Interior flooring, walls, and ceilings were reduced by 58% compared to industry average. These were product categories we found to be really far ahead of other product categories and offered a lot of great options to choose from, including carbon neutral carpet tile and ceramic tile, and also a plant-based acoustic ceiling tile, which we're excited to feature on the project. Next slide. We did go through a rigorous material vetting process to ultimately achieve these achievements. The chart on the left shows how we developed a tiered approach to decide where to focus our efforts. This tier 1 category was where we focused on materials that had highest impact, highest volume, great market availability, and we're also in highest contact with building users. And then on the right is just a snapshot of a very detailed tracking matrix we used. It's not meant to be read in detail, but it just gives you a sense of the rigorous tracking we followed to set our targets explore options for materials, and then ultimately track the selections we made. Next. For all those tier 1 materials, we went through a rigorous material vetting process that's kind of outlined here in the slide. We started with sending a questionnaire out to all manufacturers, asking for them to report their data to us for the products that we specified. If the material sent back matched our criteria, they would stay on the project. But if not, we would source new options and then start that process over again. It was an extensive process. We looked at about 142 materials, and we learned a lot along the way. Ultimately, this rigorous process was able to help us achieve the targets that we set out. So next slide. This graph shows the total reductions that we're able to achieve. So you can see we've really drilled down the embodied carbon quite a bit. It was a great achievement. But even with all of those ambitious reductions, you can never get all the way to zero. There's going to be some amount of carbon with new materials and construction activity. So we needed to consider additional mechanisms to offset them, which I'll hand back to Rami to walk us through.
Thank you, Rebecca. So when we consider this last step of embodied decarbonization, it really focuses on what can we do to offset that unavoidable carbon that gets introduced to the project. And we do that through carbon reduction projects, ideally, again, as locally as we possibly can. We considered a few different options for the AIA headquarters, be it local school or library, electrification, but ultimately we went for the most controlled approach and sure approach, which was investing in local solar projects. And so throughout the Virginia area, the AIA was able to invest in homes within disenfranchised or disadvantaged communities to donate these solar systems that would, number one, provide financial benefit for those homes and those communities, but also their emissions impact of those could be attributed to the AIA. So making an impact in the community while also being in line with AIA's targets and project goals to fully decarbonize. With this, they were able to apply these systems to about 78, almost 80 homes. Each home receives about almost a $900 savings in annual energy costs, or about 65% of their annual energy use. So a noticeable impact to the cost of living for the local community within Virginia. Okay. And this project is effectively complete at this point. These systems are all operating and well on track to meet the projected carbon emission reductions that were set out in our early calculation and concept stage. Okay. Okay, and this is that last piece of the EPIC tool where we looked at over time, when you take into account things like slow but gradual grid decarbonization and the impact of that solar generation over time, how does that at year 25 offset the entirety of the material emissions introduced to the project with the interior improvement? All right, and this is our, from the early interview, from the RFP stage, we had established a carbon budget for the project, and we are actually right there, within a few percentage points of that, at our 100% CD after our full whole building life cycle carbon analysis. So exciting to see that process when you have that integrated team that's all driving towards the same goal, how that can become a reality with this focus.